Let's take a look at this formula. So that is the K-Bessel function, which describes the local spectral analysis near the cone point P on a cone. In particular, we're looking at these radial L2 decaying solutions. There's also these S1 angular solutions. And so a sum means we're adding these local contributions up. So if we were to multiply by 2 here and multiply by square root of S, basically get 8 here, and this would go over here. So that the 8 that's there is going to come from our 8 copies of these. Now they get glued together in pairs to get this 4 right here. And that can be seen by just gluing this cone to that cone for all of the 8 copies, so we get 4. Now this right here relates the spectral side to the arithmetic side. And this is a Casimir force calculation, which I will go through the derivation of in another short or video. So since we form this guy, we form actually 4 copies of this guy. And we get a connected complex out of these 4 copies. So that sort of intersect transversely. Now if you extract their pairwise intersections, we get these 2 ellipses that are transversal or orthogonal. Actually, we get 3 more copies, but this is on the z equals 0 slice. Basically have this metric, which is a action angle coordinates, and it is a warped product metric describing a surface of revolution. If we think of this as summing up to a given certain threshold, summing up these radial components up to a given threshold. So we sum up here, then we're gonna add more, we're gonna add more, until we make it so that we hit this slice, and that we basically sum up so that this Casimir force is situated entirely on the graph, the gamma graph here at z equals 0, and for gamma sub x, gamma sub y too. Think about all of these cone points, these 8 cone points coming from different directions and hitting this graph complex at the same time. You can imagine why the force would be so high.